This is a video for AQA Further Pure Mathematics, Algebra and Graphs section 1.2, where we're looking at sketching graphs of rational functions. Well, in the first video we discussed the idea of what we mean by a rational function. So this is one where we have p of x over q of x, where p and q are both polynomials. So there's just a series of steps we need to go through to sketch a graph. Now, the first one is to first find where the graph cuts the axes. So we know that we're going to cut the x-axis when y is equal to 0, and that will be true when p of x is equal to 0. And we'll cut the x-axis when we've got x equal to 0. Once we've worked out where it's cutting the axes, the next step is to look for vertical asymptotes. A vertical asymptote is going to occur where the denominator q is equal to 0, and so we can find that, and then we should look at what happens just either side of that vertical asymptote. Then we should look at what happens as x approaches infinity or negative infinity. So in other words, when x becomes larger and larger, what happens to the value of y? When we've done those three steps, then we should have a series of points and lines on our graph, and almost like joining the dots, as it were, we can then complete the sketch of the graph. Now I should emphasize that we're not plotting here. We're not worried about exactly where points are in a graph. We are definitely just thinking about the shape of the graph and its very broad behavior. So notice we're going to go through a couple of examples of this happening in practice. The first one then is the graph of y equals 2x minus 1 and x over x minus 1, which we considered in the first video. We know that when y is equal to 0, then we must have 2x minus 1 is equal to 0. In other words, x is equal to 0.5. So it cuts the x-axis at a value of 0.5 at this point here. X equal to 0, on the other hand, gives us y is equal to negative 1 over a negative 1, which is equal to 1. So it cuts the y-axis at 0, 1, about here. So this is 0.5 and 1. 0.5 on the x-axis, 1 on the y-axis. The second step is to find vertical asymptotes. So we want to know, are there any values which make the denominator equal to 0? And we can see then that the vertical asymptote must be when x is equal to 1. So we can indicate that by a vertical dotted line coming down through x equal to 1. Now for behavior either side of that, there are a couple of techniques you can use. One is to just think about the values of y just either side. So we could, for example, try x equal to 0.9, and we'll see that y is very large and negative at that value, so therefore we see that y is approaching negative infinity. Or we can go to the other side, x is equal to 1.1, and then we'll see that y is large and positive, so y is approaching positive infinity. So to the left of the line we've got the graph doing this, going down to negative infinity, and to the right it's very large and positive. The next step is to examine what happens when we have large values of x. So if x approaches plus or minus infinity, then we can see that y is approaching 2x over x. We can ignore the small values -1 on the numerator and the denominator, and this is equal to 2. Draw that one in at 2, and then we can consider what happens either side of that horizontal. Well, for x is large and positive, then y is approaching 2, just a little bit greater than 2. So if x is positive, then we can see that y is greater than 2, so it's approaching from above. If x is negative, sorry, I beg your pardon, x is less than 1, rather, then we can see that y is always less than 2, and therefore y is approaching from below. So we can then join in or put a line indicating that either side of our horizontal asymptote. Now that we've got all that done, the final step is simply to complete the graph. We, in other words, join these dots together, and that we would do trying to make sure we go through the points that we've indicated on the axes. And there it is, completed. So now look at a slightly more complex example, but the steps are exactly the same as in the first one. So firstly, where does the graph cut the axis? Well, if y is equal to 0, then we have that x must be equal to 1. So it's going to cut the x-axis at 1. You should just check that the denominator is not equal to 0 at the same value. So if we put x equal to 1 into the bottom line, we get 1 minus 1 minus 2, which is definitely not 0. If x is equal to 0, then we can see that we have y being equal to -1 over -2, which is 1/2, so it cuts the y-axis at a half. So we have 1 on the x-axis, 0.5 on the y-axis. Vertical asymptotes occur where the denominator is 0, so the denominator x squared minus x minus 2, well, that will factorize as x minus 2 and x plus 1, and therefore we have vertical asymptotes at x is equal to 2 and x is equal to -1. Now we should indicate those on our diagram by a line coming vertically, dotted line coming through -1, and another dotted line coming through x equal to 2. So those are our vertical asymptotes, which are indicated there. The behavior of those, you can see that the value of y is positive to the right of 2 and negative to the left of 2, and likewise for -1. You can do that by just checking the values either side of those asymptotes. The next step then is to think about what happens when x is large. Well, if x is large, then y approaches x over x squared. And if x over x squared, that's the same as 1 over x, so that's equal to 0. So drawing that onto the graph, we have looking like 1 over x in this position and there. So as x gets larger, positive or negative, then y approaches 1 over x. And of course then the final step is to join all of those parts that we've identified together, and it is just a case of literally joining the dots, trying to get the graph going through the points on the axes and looking reasonable. And there's our graph of y equals x minus 1 over x squared minus x minus 2. Well, that's the end of this video on sketching graphs. In the next video we'll look at how we can locate any turning points that there are on graphs, should there be any.